All right, thank you, ladies and gentlemen. So we'll be quickly doing a video walkthrough for the memo for the 2018 SSA that was uploaded. I'm not going to be creating the stuff from scratch except for some of them, so I'll just be describing the answers, so it shouldn't take too long. So let's take a look. All right, so firstly, if we are looking at the UML question, which remember in this particular test is only 5 marks, worth 5 marks. So you don't actually have to go into as much detail, say with semester test 1 where it was worth 10 marks. So if there are some things you left out or things you didn't do that weren't explicitly asked for, then you're not going to lose marks for it, so don't worry. So for example, in this case, we have 4 fundamental forces in the universe, namely electromagnetic, weak nuclear binding force, strong nuclear binding force, and gravity. Each fundamental force is governed by a set of equations represented as an array of strings. These equations can be updated as our understanding improves. Each fundamental force is able to exert an influence, although the exact mechanism differs for each force. The universe contains these forces. All right, so we've got a class to represent the fundamental forces. We have a container of some sort called equations of strings. I made it an array type, the actual C++ standard array type, but it's, remember, UML isn't C++, so as long as you represent it somehow, it's fine. And you can see that the fundamental force is contained by the universe. We didn't specify if it was composition or delegation, composition or aggregation. So I went with aggregation. Potentially the forces exist outside of the universe, and maybe there are other universes that exist as well. I don't know, but it doesn't matter. The question didn't specify. So either kind of containment relationship would be fine. If it spoke about life cycle management, then obviously it would have to be composition, but it didn't. And then you can see on the container side, there is a container of these forces, in this case, just a fixed length array of size 4. But again, it doesn't matter as long as it's something that could potentially contain several of them, even a pointer for a dynamic array, that would be fine as well. Or just something like array of forces or whatever. And then we've got some constructors. I didn't really go into much detail about them in this particular version, so it's nice to have, but not important. The important things are the updates equations, because it did say we needed to be able to do that, and the exert force function. It didn't, or exert influence function. It didn't say what the force, or how it would work, so we went with the void function. If it's not specified, then you can go with whatever seems reasonable. And then we have our 4 derived classes linked by the inheritance arrow, and they override that function. Strictly speaking, they should really also have constructors of their own, because constructors aren't inherited. But we will need to make sure that that's the case in a real program for a 5-mark design. It's not an issue. All right, so for 1.2, an abstract base class has at least one pure virtual function. That's what defines an abstract base class, having an unimplemented pure virtual function. Whether it's declared inside the class or if it's inherited but not defined, then it will still be an abstract base class. Changing the behavior of a non-virtual function in a derived class is called redefining. If it were a virtual function, it would be called overriding. There are differences in how it's implemented internally in terms of overriding using virtual method tables and redefining simply calculating the address of the function. Obviously, if you want polymorphism, it has to be overriding. If you don't care for that, then it's redefining is fine, but that's the difference. Non-virtual, redefine, virtual, override. All operators should be implemented as member functions, patently false, because some can't be, for example, the stream operators. Which of the following considers the act of reusing code in a hazard relationship? That's the actual delegation itself. The composition and aggregation is the hazard part of the relationship. The delegation is where the reuse takes place, because that's where the work gets passed off to the contained class. For an is a relationship, the equivalent would maybe be the polymorphism, for example, the polymorphic call. Of course, in our semester test 2, we combined them together. We had a polymorphic delegation to a contained class. So it's not mutually exclusive, but in terms of the hazard relationship, the reuse comes through delegation. Which of the following represents an is a relationship? And that must be inheritance. Inheritance, that's the Polymorphism is the fact that the declared type of the class isn't used, but its actual type is used when mapping the invocation of a function to its implementation in memory. Composition, aggregation, or Hazer relationships, and we just discussed delegation. Define the following. You won't get definition questions like that so much. You'd more likely get an applied definition, but still. A generic class is a container of type T. So remember, don't confuse generics, which means templates, i.e. containers of type T, with general. So the more general class in an inheritance hierarchy is the one that's higher up on the tree. A generic container is a templated container. Encapsulation, that's data and behavior together into a single entity. And information hiding is managing the complexity of a class by separating its interface and implementation. When we're talking classes, well, it's not only classes, but when we're talking classes, we then specifically probably looking for public, private, and if there's inheritance protected. Right, are all abstract-based classes necessarily abstract data types? Why or why not? And the answer is absolutely not, because abstract-based class simply means it has an undefined pure virtual function within it. If it had been overridden with some details, then it wouldn't be an abstract base class, but none of that forces it to be an abstract data type. To be an abstract data type, that's a logical, or that's a goal. That means the logical properties are separate from the implementation details. For 1.9, describe the action taken when the following operations are performed. For NQ, that's where we add to the back of a queue, and DQ, that's where we remove from the front of the queue. We've encountered several kinds of problems throughout the course of the semester. The diamond problem, that's where you have conflicting definitions when you're using multiple inheritance for the same method coming from different parents. So solution, don't use multiple inheritance. That's what most languages do. Otherwise, you avoid or detect the conflicting inherited implementations. And there's some languages that will sort of order all of the implementations according to a fixed traversal of the tree, and then that's now a linear sequence, and they'll simply take the first one. That's a linearization based approach, but you don't have to worry about that. Easiest thing to do is to simply not use multiple inheritance, and we never use it unless it's really absolutely necessary. Slicing problem means that you've lost information by storing a derived class that's stack allocated into a base class that's stack allocated. The assignment is legal, but the space isn't the same because the base class will be smaller than the derived class. So you avoid that by not using the stack, rather by allocating memory from the free store, which will give you back a pointer, and then you can do all the pointer assignments you want because pointers are just memory addresses, so they have a fixed size. The name of a function is mangled when compiling a DLL. Well, that's why we have the extern C block in our DLL to turn off name mangling. All right, so for the actual class, we'll fill in the code. We can see here that we've got some things labeled or named in all uppercase with underscores. We can't see any types, comma separated, must be an enum. Over here, we see a bunch of data members, but they're not declared public. So whatever this is must default to public. So that's a struct. Here we see some behaviors, clearly accesses, for example, and then some data over there. So it's got data and behavior together. It must be a class. And over here we see some definitely behaviors, and then some more behaviors, and then some data. So things like the constructors and the accesses have got to be public. So D must be public. So for E, we've got our class constants. We can see their constants, but to make them only a single instance per object, sorry, a single copy of that per object, we will use static as well for E. For F, this looks like a constructor, but we've already got a constructor. It must be the destructor, so the F must be tilde. And for G, well, we've got some behaviors and some data, but clearly this data must be kept private. So this should be private or protected. These must clearly be helper functions. There's no inheritance involved, so I wouldn't go with protected. I would say simply private. Here we've got what we know is the destructor now, having worked it out, but we can see it's deleting stuff, so clearly a destructor. So in the inner loop, it's deleting the row array, so delete with square brackets. And once we're done with that, we must delete the outer array, so that's underscore array pixels, no braces, just a semicolon. Over here, we're delegating the constructors, so that's a single colon. Right, over here we are asked to define a suitable representation of one element in this data structure, which we can see as a cyclic a circular linked list. Really, there's only two that you need to worry about, and that's, is it a singly linked list or a doubly linked list? Yeah, we had weird things like the hub and other stuff like that, but we gave the definitions to you for those past papers. So don't worry about those. The ones you need to know are basically, is this a singly linked or a doubly linked list? So in this case, we can see it's singly linked. The fact that it's in a cycle doesn't actually affect the structure itself. So simply create a templated type with a data member, whatever you want to call it, and a link to the next node, whatever you want to call it. And there you go. So basically just a standard singly linked list node. Don't worry about the fact that it's cyclic. It doesn't actually matter. Okay, this you didn't do. What is meant by the acronym RAII? Well, look, we did it. We told, in the sense that we told you what a good use for constructors and destructors were. But we never studied it as an actual design pattern, which is unfortunate because it is quite cool. But we did have to balance our time. So that was something in practical C++ programming, use it all the time. The idea is fairly simple, and we've said it a lot to you. It's basically that you will allocate your resources in a constructor and release them in the destructor. So if you've got something like a file that you need to manage, you will open the file in the constructor, have accesses and mutators and whatever for reading and writing to the file, and then close the file in a destructor, because the destructor is the only thing that's guaranteed to run deterministically if an exception happens. And things with file handling, there could, for example, be exceptions. So you want to make sure files always get closed, and the one thing that's always guaranteed to close or to run is the destructor. So that's the basic idea. There's tricks to it, like for example, disabling new by implementing overriding the new operator, overloading the new operator privately, and so on. But those are all just making the class sort of more robust. The basic idea is simple. Funnily enough, it's got nothing to do with initialization so much. Resource acquisition is initialization, isn't the best algorithm, it's acronym or initialism. It's more to do with allocating in constructors and deallocating in destructors, specifically the deallocating or releasing of the resource in the destructor, because that's the only thing that's guaranteed to run when an exception happens. All right, compare and contrast two approaches to error handling, let's say assertions and exceptions. So assertions, you could say things like they're intended for programmer errors. They're for the programmers to test their preconditions, their assumptions. They can be disabled through compiler flags or through hash defines. And with, let's say, exception handling, their goal is to separate the detection of an error from the handling of the errors. They also allow you to use inheritance to define an exception hierarchy so that you can use the relationship between kinds of errors in your error handling. You specifically demarcate a region of the code for being potentially error prone with tries. There's lots you could say about them that differentiate them. Name three restrictions which exist on operator overloading. Well, you can't overload all operators. You can't change the arity of operators, as in their number of arguments, and you can't change the precedence of operators. So you can't make plus bind at the same level as multiplication. So you can't change the BODMAS rules, basically. BEDMAS, PEMDAS, however you learned it. And then what else? So, and you can't change the associativity of operators. So you can't make left associative operator right associative. For example, remember, associativity is the order in which operators are evaluated if they have the same level of precedence. So that's plenty. All right, so the DQ operation of a queue can be implemented using a doubly linked list. Draw a series of diagrams showing the removal of an item from a list. I'm not going to draw it, but basically we would need to see the arrows going in both directions because it's doubly linked. You'll be removing from the front because it's a queue. So basically we just need to see the head pointer being updated to point to the second node. something still pointing to the old head to allow us to delete it, and then the old head disappearing, and then the predecessor, the backwards pointing node or link for the new head must then point to null. That's basically the things we need to see. Right, so here we've got file handling. I don't know why it was called .dat. I normally call them .text with the text file, but it's clearly a text file because you can see end of line. So it basically represents plots of lands. So owner ID is a number, which is an alphanumeric string, no longer than 32 characters. Earth number is an unsigned integer representing the plot. Value is a real number representing the market value of the property. Business rights is Boolean, indicating whether it has business rights, and end of line is end of line. Fixed length, no variance, no need to use a string stream and get line. We can just do it with a straight up old simple loop. Most of the marks will come from the file handling. So for example, so only a little bit comes from the finding the most valuable property, but that's just a simple max loop, so it's only 1 mark's worth. And then please show code for the opening and closing of the file. So this is the only place you're supposed to get marks for showing the closing of the file. But if you forget to do it there and do remember to do it elsewhere, we'll still give it to you. But you only get marks for closing the file once, because that is the same all the time. Otherwise, you'd get 2 marks for everything just by opening and closing the files. So you only get that once. All right, so you don't have to handle any errors. So let's do it. Kind of messily. It's input, so we'll use an IF stream. What was it called? Land allocation, land allocation dot dat for whatever reason. Use the constructor, don't need to call dot open. It's an IF stream, so we don't need to specify the flags. So we're good to go. Close it. So 2 marks already. And then what do we need to do? We need to define our variables for handling these things. So I'm going to use C++ strings for now, for example, for the owner. But later on, you'll see we can't stick to that forever. And then what do we want? Earth numbers, that's an unsigned integer. And then the value, so that's double. Would initialize these, I suppose, but we'll get assigned values in a moment. And then business rights is Boolean. We don't mark the cold code like this very strictly in terms of errors, so obviously there's no compiling, but if you make a mistake, a small mistake, don't worry about it. How do you spell business rights? I'm just going to call it rights. I think that's all of them. Yeah, and then all you need to do is to do a simple little loop, streaming from file into owner into at into the value and into, well, actually rights would have to handle a little bit differently. So funnily enough, didn't say what would represent what. So I'm going to assume that it's a numerical value that will correspond to C++'s underlying implementation of true and false. So we don't have to do any checks for a Y or a T or whatever. So, but if you did that, that would be fine as well, because it wasn't specified. And then inside our loop, we've now got it. So all we need is to do a simple max check. So we just need to have our value. So strictly speaking, the first one is the one that should be the initial value, but I'm going to take a slight liberty because it's a short question and just assume that there's some min value, or that's nothing can be worth less than 0 or whatever, just to start it off. I'm not going to worry too much about that. And then if dvl value is greater than, oh, sorry, dvl max Then what do they want us to spit out? They wanted us to print out the earth number, so we'll have to keep track of that as well. It'll be updated as we go along. And then when we're done, we can simply output the earth number as specified. But I mean, all of this is really just worth 1 mark. Sorry, not all of that, but just the logic for finding the max. This is obviously more important, the while loop that governs everything, and opening and closing and setting up the variables. So that's that. Define a structure with alignment padding or packing disabled to represent the data for 1 plot of land. You may assume that the owner name contains no spaces, and you need as much as precision as possible to store real numbers. That just means use a double rather than a float. You do not have to handle any errors. I mean, if you know about other types that have higher precision, you go for it, but all of the ones we've discussed, that's fine. So that's just defining the struct. So basically, all we need there is, and lots of the marks here will come from disabling the packing. So for one thing, back up the old packing alignment, minimum, define the actual struct, call it, and what did they say? So it was, so very important for the owner. You can't use a C++ string. You have to use a fixed length character array because each of the records needs to be the same length. So if you use a string that's variable length, it's not going to work. And then we wanted the earth number. And the value. And the business rights. Did I remember to do the business rights in the previous code? Maybe I forgot it. If so, don't forget to read in the business rights in the while loop. All right, so bool. There we have it. All right, and yeah. Then don't forget at the end to reset the packing alignment to whatever the old value was by popping it off the clearly stack that it's stored on. All right, you don't have to handle any errors. Okay, fine, so that's done. And then assume that the dat file now again is a binary file of records. So now just pretend it's a binary file of records. The previous one was clearly a typo, should have been .text. Define a question 3.2, write code which first calculates the number of records in the file, reads through every record, and then writes the earth number of those entries with a negative value. With a negative value to a text file called follow-up.txt. So actually, good thing we didn't set that to 0 as our max, as our starting value, because it's quite possible that it's not that. All right, so here we go. So now it's file handling with a binary file of records. Although it's not strictly speaking necessary, I tend to use F streams only for binary files of records. So I'll continue with that since I tend to need to specify the flags anyway. That's what we'll do. And so this was now land, acquit, and allocations. Allocations.dat. We need to open it in binary mode. And we need to open it for inputs. Still close it, even though I won't get the mark the second time. I will get marks for opening it now because there's more information that I need to specify. And we needed to count the number of records first. So let's do that. So how do we do that? Well, firstly, we will move to the end of the file. So that means we're moving 0 bytes away from the end. And the number of records is going to be the byte value at the end divided by the size of the structure. Okay, presumably we'll then want to move back to the beginning. No, start. The top of my brain is not working, but anyway, we're moving to 0 bytes away from the beginning. Then we can read through them all. So we'll need a record to do that. And then we can use a for loop now that we've actually calculated the length. So you could just keep reading until you hit a end of file state as well, but this is fine. And then we'll do the actual read operation, which will be worth quite a lot of marks. So f.read, it's low level. What do we need? We need to specify the place where we want it to be stored. So that's going to be the address of rec land and how many bytes we want to read. That's going to be size of land, but this doesn't understand what a land pointer is. It only understands char pointers. So we need to turn it into a char pointer through a reinterpret cast to char pointer of that address. And now we've got our read operation. And now we can simply check if recland.dbl value is less than 0. Now we have to write this into a separate file for text. So this is quite a big one, unusually large. So then what are we going to do? We're going to have that open already. So I have a separate file. Let's say follow-up.text, I think they called it. Yeah. And then that's good. Well, and then we simply can write to f out. We can use the stream operator and simply write the earth number, which was recland dot earth. Need some sort of a separator, so let's assume it's an end of line, and good to go. All right, so we've got the analysis of algorithms. Let's see how we. So the main thing with the analysis of algorithms question is basically you write down your assumptions. So those assumptions will be which things we're going to count, which operations we're going to count. It doesn't matter if you pick the same as the next person, and it doesn't matter if you pick them differently. And then also it's you need to say that there's a fair measure of complexity, and you need to say that they are you need to define T of n, and you need to let that be your time value. And then you need to count the primitive operations, which in this case is going to be very easy. Let's say we counted allocations and assignments and anything that looks reasonable. So 1, 2, 3, 4, 5, 6, 7. And we could even count the member accesses if we wanted. So whatever, we count them all. It's going to be some blob. We can say that this is a function that contains no loops. Because we assumed a fair measure of complexity, we assume that things like exit, cr don't contain loops, although actually, strictly speaking, it'll loop over the C string there, but it's not tied to any input size. There is technically no input size here. It's a fixed number of operations always, so we'll get some constant value when we count these up, and then when we take the big O operator, we're going to get big O of 1. So that's basically that. So for the question 4, for writing the header file, you can see it'll basically be the same as the one in the notes, except modified to have this particular function. So important things to look about will be the doing the hash defines for the declaration of the function. So hash if not defined, or if defined, whatever thing you sent through, let's say this is build DLL, then you will define your decoration as being, let's call it DLL fun, or DLL un, whatever, DLL fun, as being DLL export, and then otherwise same story, but import also marks for the basic guard conditions if you've called the library. And then your extern C block with this function in it, decorated. And then that prototype for the function. Strictly speaking, the string isn't C, but and the UJ image either, but that's fine. The question we just want the name mangling off. And then write code which shows how to explicitly link to the DLL and extract and run the function. That's going to be the same as the code that we did, except that the only thing that's going to change for that will be that this is the signature of the function you're going to extract. So windows.h, h instance, load library, get proc address, cast it to your function pointer type, call the function, check for errors, free library, done. All right, so thank you very much. That's that. Goodbye.